Hey, I just want to do a quick video to teach you this awesome trick for how to find the velocity of the center of mass of a system and also how to find the net force on a system. And both these things do come up on the AP test. If you don't know the trick, it's kind of hard, so here you go. I'm going to make it easy for you. So here's the thing to keep in mind. I think all of you by now know that the momentum equation is momentum is equal to mass times velocity. Okay, that's for one object, right? If I want to know the momentum of an object, I have to know its mass and its velocity. But I can do the same thing for a two-object system, right? So in that case, what I do is I just put the word system after each of these things. So the momentum of the system is equal to the mass of the system times the velocity of the system. And the velocity of the system is the velocity of the COM, of the center of mass, okay? So let's just see how this would work, okay? So here I got a system, a two-object system before the collision. I've got a 6 kilogram object moving at 3 to the positive direction and a 2 kilogram mass moving in the negative direction at 4. So I'm going to say momentum of the system is equal to the mass of the system times the velocity of the system. So what's the momentum of the system? Well, it's 6 times 3 plus 2 times negative 4, which is 10. And the mass of the system is 6 plus 2, that's 8. So the velocity of the center mass of the system, 10 over 8, or 5 over 4 meters per second. Easy, right? That's so easy, okay? So look what happens after the collision. Should get the same thing since momentum is going to be conserved here if no outside force acting on the system, which in this case it's not. Again, momentum of the system is equal to the mass of the system times the velocity of the system. Now in this case, the momentum of the system is 6 traveling at 1 plus 2 at positive 2. So that's 6 plus 4, that's 10 divided by 8. Oh, look, I still get positive 5.4. So easy, right? So if you want to know the velocity of the center mass of a system, you just have to remember the momentum equation. That's all you got to do, is just apply it to the system rather than an individual object. Now I can also use this with the impulse equation to figure out what the net force is on a system. And this comes up a bit on the AP test. And so it's again, if you don't know the trick, it's hard, but if you know the trick, it's super easy. So I'm just going to take the impulse equation, which these are the two equations from this unit, right? Momentum and impulse. So impulse, which is force times time, is equal to change in momentum. Now, I will say, when you're dealing with a system, it's better to think in terms of delta momentum rather than m delta v, because m delta v works when you have one object changes velocity. But now I got two objects that both change velocity. It can get confusing. So instead, you just say, all I care about is the force on the system times the time that force acts is equal to the change in the momentum of the system. Well, let's try this, okay? So let's just say I have this rocket-powered object, okay? It is traveling at 8 meters per second, has 1 kilogram of mass, is going to collide with and stick to a 3 kilogram mass, which is initially at rest. 2 seconds later, this combined two-object system is now traveling in the positive direction at 8 meters per second. So notice there's no change in velocity here over the course of those 2 seconds, but let's just see what's true about the net force, okay? So what I would do is I would just say, all right, look, I want to say the force on the system times the time that force acts is equal to the change in the momentum of the system. So I had to first find what is the change in the momentum of the system. So the momentum of the system before was 8 times 1. Made it pretty easy for myself, right? So it's just 8 plus 3 times 0. So the momentum was 8 initially. At the end, the combined 4 kilograms of matter is traveling at 8, so that gives me a momentum of 32. All right, well, delta always means final minus initial, so 32 minus 8 gives me 24 units of momentum, which is really just kilogram meters per second. So then I'm just going to put, I'm going to substitute this value here in for momentum of the system. I want to solve for the force on the system. And I know that the amount of time was 2 seconds, so I get the net force acting on the system was 12 newtons. It wasn't very hard. Now, this force could be friction, it could be, in this case, an applied force, it could be a gravitational force. It doesn't matter. This works no matter what. It's super easy. So thanks for watching, and I hope this helps.